Hello, Midnight Coders, and welcome to another episode of the Midnight Coder. So, controllers translate, repositories persist, and services make decisions. If you've ever written CRUD that worked and then had no idea how to extend upon it without breaking everything, then this episode is for you. Today, we are going to create our user, save them, but more importantly, we're going to make some decisions about our service implementation. So, make sure you've got that full cup of coffee. Let's dive on in. Let's start by opening our user. Now, in here, there's a little bit of information that we want to do. Uh, for example, whenever we create a user object, we want to do a couple of things, make sure that the identity is valid, but also we want to make sure that the created time is being set as well as the status being assigned to private or pending. So, how do we do that? Just simply make a void. We'll call it on create, and we'll do a check to see if the ID is null. So it hasn't been assigned yet. Then we want to say that the ID is equal to the UUID random string. There we go. Now, from here, we're going to, again, set up the status. So this dot status is pending. We're making this pending because in the future, we might want to have our users validate their email before making them an active user. And also we want to set created equal to local date.now. So how do we ensure that um, this happens whenever we create an object? Spring Boot has a uh, great annotation, as they do for everything. We can just annotate this with persist. And now, before we persist our information for the first time, or before we persist it, um, it will run this method. We can also, if we wanted to ensure that, say, an updated time was always performed, then we could do things such as pre-update, which essentially would be this happens anytime before we update our entity. Moving on, we will look into our repository next. And in here, it is pretty bare. Here, we use an interface to communicate with our database. Repositories are interfaces because the business does not care how the data is stored, just that we can create, read, update, and delete information from it. When I'm writing business logic, I don't really care if the data lives in Postgres, Mongo, Redis, or some other database. I only care that I can save a user, fetch a user, and do what I expect. So now in here, one of these things that I care about doing is checking to see if something exists. So I'm going to write a quick Boolean that to see if it exists by email. I'm going to write another one to be able to find a user based on an email. But I'm not using this raw usage that it provides here. Um, I am going to wrap this in an optional. So that way there is some null safety being done, and I can handle it appropriate. So next, we are going to look at the service. Here, we have a way to just register a user. So if we pop into our implementation, service layer is where the system decides what is allowed to happen. Not how data is stored, not how HTTP requests work, and not how objects are serialized. Business logic is decision-making logic. A user can only create a team if they have an active profile. A project cannot have more, or sorry, a project must have an owner. And an invitation link can't be accepted if it's already expired, and some things like that. So now in here, there is a couple of things that we need to do to be able to register our user. First of all, we want to check to see if the user already exists. So we're going to create a variable and just call this exists. And this is going to be equal to, look at that, it knew what we were doing, except I believe, oh, this is because we do not have getters. Now if we pop into our, or sorry, we have a record. So this doesn't use the same type of getter. It uses an email getter, or sorry, just a lowercase getter. So next we want to see if the user doesn't exist. We're just going to simply, sorry, if the user does exist, we're going to just simply return null. Otherwise, we know this email doesn't exist. So we want to build out our model. So here I'm going to simply say var model equals new user. And from here, I'm going to simply say model dot set Nope, we didn't add any getters or setters into our model. So I'm going to pop into here and we are going to generate getters and setters for everything. Just a go. We'll pop back in here. Set email, which is going to be equal to the email. Next, we're going to set the password hash, but we don't want to just store the raw password. We need a way to encrypt that. So let's also, all we need there, because everything else will be created upon persistence. So very much so we are going to do that, although I do want to return the cached version of that so that I can, or so that we can then build out the response. So now down here, we're going to rebuild out the response. And what's that? Created it. That's why. So here, hash.create. There we are. So now up here, we want a way to, and of course, we're going to return that response. So now, Force IntelliJ is telling me that I can just make that an inline reply. Um, so now, how do we go about securing the password? Up here, we're going to have to create a little bean so that we can use this for our verification. So let's make a bean. This one is going to be public password encoder. And there we go. So we're going to do a password encoder, and we're going to be using decrypt as our encoder. Now we can come down here and say password encoder dot encode, and okay, because I should probably not call it a bean indirectly in here. Um, so we're just going to call this out here. So now when we call our register, it will verify the user exists. If we do exist, we just stop right there. If we do not exist, we go ahead and create ourselves, we save ourselves, and we reply with a cached version of ourselves. Finally, we go take a look at the controller. So in here, when a user creates a request and they post it to our domain slash auth slash registry, we attempt to register. So here is where we say that our registration, which is our response, is equal to our service.register. And if that happens to be null, there was a bad request. Else, we are going to just return with that reply that we've got. The controllers exist at the edge of your system. So edge code tends to change frequently, whereas business rules do not. What we're returning is a DTO, or a data transfer object. DTOs protect your domain from the outside world. Controllers deal with JSON, validation, HTTP, HTTPS responses and requests. A DTO represents two different things. A request DTO represents user's intent. A response DTO is a safe public view of data. So no sensitive or database identifying information gets leaked into your business. Today, We took the models that we designed earlier and we had brought them to life. We defined repositories' persistence capabilities. We've set ourselves up for business logic in the service layer, and our controllers are thin and predictable. DTOs help create explicit boundaries to protect our data. In the next video, we'll have a look at our project module and take a deeper look at some of the topics that we've covered today. Because today we've just created some of the necessary CRUD actions. So if you've made it this far, thank you very much for watching, and I hope you've learned something. Hit that like button if you did, and if you'd like to learn more, remember to hit that subscribe button and turn on notifications to be notified of when I go live or when I post the next episode. And if you know a friend that might find this useful, remember to share the playlist. And as always, keep your curiosity open, your skills sharp, and that coffee cup full. I'll catch you in the next one.